these because I know you didn't. If you didn't work them, you should have at least the questions pulled up and looking at things as I go along, go through them. Um, all right, so for number one, you had to make sure you read the questions and stuff properly, et cetera, et cetera. So they want the first thing they tell you to do is write an equation for the local linear approximation or locally linear approximation. Um, Basically, that means locally is just around that point. So we talked about when we do linear approximations, the further we get away from the point, the more it's going to be off. So we're only doing, so the linear approximation at t equals 3 is only viable for numbers around 3, like maybe 2 to 4 area. Once you start getting further away than that, they start to become very off in most cases. We talked about that when we did tangent lines. So the first thing is, how do we write the linear approximation? We've done this yesterday, so I'm going to assume people hopefully remember part of it. How do we write a linear approximation?
I mean, I remember the formula.
Well, what is the formula then, Ms. Bridget?
Point slope.
L of x minus f of a equals f prime of a times x minus.
Okay, let's make it a lot easier.
Point
I
slope.
don't know how to do it.
Y minus y1 equals m x minus x1.
Wait, really? Oh, wow, that makes sense. I see it now.
I said that yesterday. Well, if you want to remember the fancy form, remember this is L of x, this is f of a, this is f prime of a, and then this is x minus a. And then you can move the f of a over if you want to. That is your fancy line. So we need...
Is anyone else watching the stream?
I would hope so. Okay, so we're not going to use the funny one, we're going to use the regular one. So y is our linear approximation. Slope, how do we find the slope of whatever function they called this?
Take derivative.
Okay, so it is, we got to be careful because we have two functions. We have f of t and L of t. So,
Do we take it of f?
No, because if we look, we're looking for w, linear approximation for w, so that means that that is w prime of t.
Oh, okay.
So we need w prime, what's the time, 3, I think it was? X minus 3 plus... I think we need the linear approximation at 3, and then we're going to ask for 2.5, if I read right. Yeah, so see how it says write an equation for the local linear approximation of w at t equals 3.
Whoa.
So that means 3 is our a value at this point.
Wait, what is W?
Why do you have p?
Why? I don't have p.
What?
That's not a p?
Anybody else see a p?
No, not at all.
Okay, making sure.
Maybe I have the wrong, stream.
Refresh your page, maybe. Okay. So the question is, some of this is pretty easy. We should know what w of 3 is. What is w of 3?
Still have a p.
What do you mean a p?
And go to the bathroom.
It's like what? Oh, okay, there it is.
Okay. I'm like, I don't know.
It's like y minus 6 equals p prime of 2 times x minus 2.
That was definitely from yesterday, I assume. I don't know. Okay, so the question is, what is... So we should know what w of 3 is. They give it to us in the question. What's w of 3?
2.5.
That's 2.5. The question is, what is w prime? We have to understand and read in that w is the amount of water in the tub or whatever. So w prime, when we take a derivative of an amount, what do we get?
The rate.
We get the rate. So we need the rate of the amount of water in the thing. So our w prime of 3 will be equal to, what they call it, P and L or some crap?
F and L?
Thomas, shut up.
F and L. So F is what? Falling? Flowing? Okay, Jesus Christ. So
The
W
water
prime.
going in is F, and the water coming out is L.
Yep. So our W prime of 3 will be equal to F of 3 minus L of 3. The amount coming in minus the amount leaving. So for instance, if I have 10 gallons coming in every minute and 5 gallons leaving every minute, that means my tub is filling up at a rate of 5 gallons. So it's getting 5 gallons more every minute. So
Wait,
what?
where did you? How do you know that W prime of 3 equals F of 3 minus L of 3?
Because W prime, as we just talked about, represents the amount or the rate at which the water is changing in the tub.
Oh.
So it could be filling up or it could be draining, depending on how much water is coming in and how much water is leaving. So the F of 3 and the L of 3. So F of 3 is how much is coming in. L of 3 is how much is leaving. If more water is coming in other words, F is bigger than L, then the rate would be positive and be filling up. If F was smaller than L, then the rate at which it's leaving would be bigger and the water would be draining out of the tub.
Okay.
So that's the connection they wanted you to make here, and this is honestly the hardest part of this question, is to figure out that's what W prime is. But remember, we have to keep that in mind, and again, as you're making notes to yourself, if you have an amount, which is W, wherever W is, when I take the derivative, that is the rate of that amount. So it's basically how much water is either entering or leaving the tub in total. So that's why I have to take into account both F and L. I don't know what that number is off the top of my head.
I don't think I would have gotten this if I tried this.
There's a reason we practice these, and I don't just throw you to the wolves.
It felt like I was being thrown to the wolves when I looked at it.
It's because I put a cage around the wolves and then put you near the cage.
Gotcha.
So, yes, that's the whole point of the practice and understanding we learn calculus, then we now put it all together and understand how we actually use calculus in the real world. So this is the kind of stuff we look at, and they, not obviously for a bathtub would we ever do this, but for other things we definitely do this. So here are your answers in case anybody wants them or has tried to get them. Your final answer should have been 2.952. So this is what, 0.904? So this is equal to...
How would you finish working this one out?
I'm not done. So the W prime of 3 is equal to the 9.904. So I can now plug in my W of 3 and my W prime. So my linear approximation would be 0.904 x minus 3 plus, was it 2.5? Right?
What?
W of 3 was 2.5, right?
Indeed.
It is.
Okay. So this is your linear approximation. That's the first step. Second step says to use that linear approximation to figure out how many gallons are in it at what time? Was that also 2.5? No, 3.5. So now they want to know what is the approximation for 3.5.
Wait,
Well,
how did you get 0.904?
that's by plugging in F of 3 minus L of 3. There are functions that you can use your calculator to figure out that answer.
Oh.
I just got it from the answer key because I didn't feel like plugging it in. So they want when time, so this really should have been a t, but it doesn't matter, when it's 3.5. So you just literally plug in. So y of 3.5 is equal to 0.904, 3.5 minus 3 plus 2.5. And whatever that equals, that was that number I gave you a minute ago. Which is 2.952. So anytime they ask you to write the linear approximation, that's a tangent line. So use point slope. Then they ask you to approximate. You plug that value into your linear approximation. Again, you should be making notes about those generic things to yourself out to the side on a paper somewhere. Deborah, stop getting text messages.
Alright, it's Annabelle.
Well, tell her to shut up and join class. Oh, hi, Annabelle, you're in class. And way to throw your friend under the bus.
What?
Okay.
Hello, I'm here.
Yes.
I kind of forgot and then like joined just now.
You're okay, sweetie. You also
I'm late to
didn't-
school.
And
I
you
we
didn't
don't
do
even
your
have a
work.
school to go to. What?
And you didn't do your work.
Oop.
Yeah, we should have the free response pulled up so you can follow along. Any questions on what I did? Obviously, I'm not
I have it
expecting.
pulled up.
That's fine. Any questions on what I did? Because I'm not expecting you to have gotten all of this. Some of this is going to take a couple practice problems before you figure out the whole idea of these. I know this.
Wait, so when we write the linear approximation, like, which one were we solving for? Was it
The
just y?
last two lines are the lines of the answers. So y equals is your linear approximation. That's the first thing you need to find. And then they wanted you to approximate 3.5, which is the last line. So y of 3.5 is equal to that.
Okay,
So,
is the last line part B? Wait, no, it's not.
no, that's the second part of part A, where it says use it to
Oh.
approximate the volume of the water.
Okay, I see.
Okay. Any questions again on what I did? And I'm not expecting 100% of you to obviously have gotten this. It's going to take a couple practice problems. We're going to do quite a few things. This is a very common question, rate in, rate out type thing. Most of them will involve integrals as well as derivatives. This section is only derivatives, so you will see more like them, don't worry. All right, part B. If you didn't understand what the W function was, it's kind of hard to find W prime or double prime. But the W function, remember, is that f of t minus the L of t idea. So here you're just taking the second derivative. So when we do that, W prime of double prime of 8 will be F prime and L prime. So we get W double prime of 8 will be equal to F prime of 8 minus L prime of 8 is what they're looking for there. So that should be, like I said, if you knew that's what the function was, it's a very easy problem. Understanding that's what the function is a little different. So here we should get what? Negative 1.83. Negative 0.183, sorry. Okay, so that part, understandable if you didn't get. However, we should be able to say what that means. So what is W prime? What does that represent? Or sorry, double prime. So, well, yes, but that's not what it represents. That is what it is.
The rate of the rate.
Okay, so we got to be careful. So what is the W function?
The amount.
Volume.
Okay.
Oh, wait, is it the rate at which the volume is changing?
No, that would be W prime. So if W is the volume, W prime is the rate at which the volume is changing. And then do another prime, which means another derivative, so it's another rate. So it's a rate of a rate, but we got to mention it properly. So it is the rate at which the rate that the volume is changing is changing. So it's very wordy, very weird, and I hate when they ask these questions, to be honest. But it's the rate of the volume changing. And then the question that you have to be careful on is what are the units of that? So we have to remember that it's quite easy. So W of t is volume, so we can just call it meters cubed. Whatever it wants to be, sets of measurement of volume. So what is W prime of t measured in?
Oh.
So if W is a volume, what is W prime of t again?
Oh, squared.
So if you can think of it as taking a derivative, so that would come down. So you're thinking that is not correct. Careful. I'm taking the derivative with respect to time because it's a function of time. So it's a rate.
Say to the 5th power, but I don't know.
No. It'll be your volume per minute. It's a rate. Rates are like meters per second, miles per hour. It's a per time thing. So when you take a derivative with respect to time, you're dividing. Remember, derivatives are slopes. So your first function would have been like meters cubed or gallons or whatever time, and it could have looked something like that. if I take the slope of this graph with meters cubed and time on the x and y axis, remember derivatives are slope, rise over run, meters cubed per time. So whatever that would be. Then this graph would be meters cubed per, in our case, minute. And then, well, I'll put minutes there and there. So what happens if I do the slope of this graph?
Meters cubed over minutes cubed? Or minutes squared?
Okay, so that's one way of doing it. So I usually start out with meters cubed per minute, which can be correctly changed to minutes cubed, or minutes squared. So we just have to remember, derivatives are just slope, rise over run. So in the water function, the gallons is the y value, time is your x value. So you're going to divide those two, and then for your derivative, this would be your unit, so again, you divide them and you keep doing it. Easy way to remember this, anytime you're taking a derivative with respect to time, you just keep putting another, whatever that time value is, so minutes in this case is what I made it, you keep putting another minutes in the denominator. So if I took a third derivative, what would I get?
M cubed over minutes cubed.
Right. So every time I take a derivative with respect to time, just add another unit of minutes. So minutes cubed per minutes, or meters cubed per minute cubed. What if I take a fourth derivative?
Minutes cubed per minute to the fourth.
Meters cubed per minute to the fourth, yes. So each time you take your derivative, you're just adding another variable in the bottom, that's the time. And that will always work that way, as long as you're taking your derivative with respect to time. Okay, part C, the tub is in the shape of a rectangle. That's a terrible tub.
Probably easier mathematically than an oval.
Yeah, it's actually pretty straightforward. Oh, I'm looking at part D, not part C. I was like, that does not match up to the answer key. Sorry, I skipped part C. Nobody said anything. Part C, is there a time t equals between 5 and 10 at which the rate of change of the volume changes from positive to negative? Okay, so again, if you know what your function is, that's an easy question. So here's the hard part, coming up with that function. So again, what is our rate function that we're talking about? Deborah, if you're going to eat, mute your microphone, please. We don't need to hear your cereal.
I'm still trying to answer.
Well, then unmute when you want to talk. We don't need to hear you chewing your cereal.
Okay.
So what is the rate of change of the volume? Again, we have to remember that is W prime. And our W prime of t will be F of t minus L of t. If we have that, this question becomes super easy. They basically said, in between 5 and 10, does W prime of t go from positive to negative? I think it was. Did they say positive or negative? I believe it was. Yes. So they're asking us, does it go from, look at that arrow, does W prime of t go from positive to negative at any point? Well, if you have that function, super easy question. So the hardest part, again, of this is to get that function, realize that. If you didn't get that, honestly, this question is very difficult, the whole thing. But at that point, you can just put these in your graphing calculator, graph them, figure out some values, et cetera, et cetera. A really nice thing to do, in case you don't know this, on the graphing calculator. So if you look at my y equals, so notice how I have a function y1 and a function y2 in there. For y3, I can then do y1 minus y2. Couple of things to point out. Notice on my graph how only the third function is graphed. The green or the red and the blue are not graphed, because if you look at them, I do not have the equal signs highlighted. All you have to do is just kind of mouse over there, or not mouse over them, highlight them, and then hit the enter button. If you notice, you can change if they're highlighted or not. So if it's highlighted, it'll show on your graph. So if I refresh my graph over here, you'll now see both the blue and the black graph. If I want to get rid of the blue graph, if I highlight it, what are you doing? And hit enter, the highlight goes away. If I refresh my graph, the blue one will no longer be there, only the black one will show. So that's a nice little neat way of using that. So you can put the original like f of t in y1, l of t in y2, and then you don't have to necessarily show them for anything, but you can still have them stored separately in case you need to do anything to them individually. That is a nice little trick for your graphing calculator. So at this point, honestly, that function is really easy. Find your zeros. Apparently this one is 0 at 8.14, so it does switch somewhere in between there because it goes from positive to negative. It's a super easy question once you know to look at f of t and l of t. Okay. And then question 3, or sorry, D, it's worth 3 points. Okay, so it's a square. It wants to know what is the rate of change at the depth of the water. So what does that mean I'm looking for? What is the rate of change at the depth of water?
W prime?
No, W prime would be the rate at which the water is entering or leaving the tub. That's not the height of the tub.
Oh.
So rate of change to the height is dH/dt. So that leads me to know right off the bat that I've got to write an equation that has a height value in it. I'm talking about volume, and I have this rectangle. So I should probably write me a volume equation for a rectangle. So could somebody help me out? What is the volume of a rectangle?
Base times width times height.
So I would say length, but yes, that is correct. Length times width times height. Now, as water is filling up your bathtub, what do we know about the length and width of your bathtub?
They're constant.
They are constants. What about the height of the bathtub? Well, height of the water in the bathtub.
The height of the water change.
Right. So as I'm doing things, we have to realize that L and W are constants. So what happens when I take the derivative of the right-hand side?
They just stay constant.
Right. So take the derivative of the left-hand side. I'm going to assume by now everybody knows that's dv dt. Derivative of the right-hand side, L and W are constants. The only variable is h. So this becomes L times W times dH dt. And if you want, and it makes you feel better about doing that, what are the length and the width?
How do you know which ones are going to be variables and which ones are constants when they're all variables?
They're not variables because think about so as water is filling up your tub, what part doesn't change?
Oh.
The length
The
and the
tub
width.
itself.
Well, you got to be careful because we say the height of the tub doesn't change, but we're talking about like the water. The length and width of the water that's filling up the tub is always going to be, what is it? 0.5 and 4. So these two variables will always be 0.5 and 4 no matter what. I can't just fill up like half my tub and have the water just sitting in half of the tub. Obviously, that's not possible. So the thing that changes in this case is the height. So if you wanted, instead of doing L and W, you can change those to 0.5 and 2. And that would be perfectly fine to do up here, 0.5 and not 2, 4. I think 4. H. And then when you take the derivative, obviously it's going to be easy. I'm going to switch that to 2 because that's bothering me. move that over. So 2 dHdt. And then you fill in your dW, or sorry, dV dt and your and sulfur dHdt. So what is, how fast is the water coming in? Oh, you gotta solve for that using this stupid thing. So it's at what, 6? So, and remember dV dt,
Can y'all not?
no they can't, is equal to W prime of t. These two are the same thing. So the rate of which the volume is changing and the W prime is the same. So if we plug in 6 to that, W prime of 6 is equal to F of 6 minus L of 6. Then you plug that into dV dt and sulfur dHdt. And again, as I'm saying this, I don't expect you to have gotten all this by yourself, but do you have questions on what I did or how I figured something out that I can help you with?
Why does dV dt equal y prime or w prime of t?
Because dV dt is the rate at which the volume is changing, and W is the rate at which the water, like W prime, is the rate at which water is coming in. So that's the same thing. Because the volume could either be, I'm going to assume the volume, well, I guess it could be. So the volume, like the water coming in, could either be more than the water going out, or
Yeah.
vice versa. So it's telling you that W prime is basically how much water total is coming in per time. That is how much the volume is changing. They're the same thing. Because dV dt would be the same, like if you think about it, it's the same units, like we talked about earlier. Volume is measured in, like, in this case, gallons or meters cubed, whatever they want to give it to us in, cubic feet per minute, and W prime of t would be the same thing. So they represent the exact same thing.
Mm. And what was the point in finding or doing the whole dHdt thing if it's just like not there?
We have to solve for dHdt. That's what you're looking for. So you get that W prime of t is what, 0.5? So this over here equals 0.5. And then you plug that in over here and you get 0.5 is equal to 2 dHdt. So dHdt is equal to 0.25. And that would be feet per minute, or whatever time they're using. So that's what the final answer they're looking for was. Okay, any questions? Okay, moving on to part B then. All right, let me erase this. So moving on to part B. Let's see, so we have a piecewise function, not too bad. I'll score Nolan's. Alright, so they gave us the function, so w prime of t should not have been hard. This one's actually a lot easier to start with, because they gave you the function, so it's not as bad as the other one. So w prime of 8. So if I'm doing w prime of 8, am I using the top function or the bottom function?
Bottom function.
Why am I hearing myself?
I don't know.
Okay. So use bottom function because it's from 6 to 8. So yes. At that point, all we have to do is just take the derivative of that function. That function's a very easy function, so it's a polynomial-esque. So A, I shouldn't have to do much work for. Your derivative should have been negative 2/5 t minus 6, parentheses, t minus 6. And your answer should have been negative 4/5. And literally everybody in this class should have been able to get that. So you can't complain and say, I didn't know how to do that. I'm looking at you, Deborah. The harder part is what is the context of the problem? What does w prime represent? So what does w represent?
The depth of the river.
So what would w prime represent?
What would be a rate? Like
Right.
the change in the depth of a river
Right.
over time?
That would be correct.
Is
So,
the depth the same thing as a height?
yes, but when you talk about water, you say depths instead. Because we measure from the top down, so we call that a depth. If we were measuring from the bottom up, we call it a height.
Oh.
Oh,
The fact that I just got 2 O's.
I never knew that.
Okay. Yes, that's why when we talk about water, you say like the depth of the water. It's like a 5-meter deep pool or whatever. You don't say it's a 5-meter tall pool. So, yes, that is why that you do that. So it's so that because we know we're measuring from the top down, and if we say the height, like a height of a building, you don't say the depth of a building. You also could use depth, like if you're talking about like art, like when you have like 3D pictures, you talk about the depth perception and stuff like that. So depth could be like from starting from the front and going backwards. That would be depth as well. That's why we call it depth perception. So if you can look at something and see how far away it is, that's because you can see how far back it is. That's the same kind of thing. If you start from the beginning and go forward, like that, like if you're going into it, that's what we call depth. Okay. So it would be the rate at which the river's depth is changing. So in this case, the depth is, your W prime should have been, is negative 4/5. So the river is getting shallower, you could say, getting less deep. It's changing at
What are you?
4B part A. Where are you?
A?
Do you not see W of t? The piecewise function?
Well, no, I do.
Do you not see where it says the very next line, the depth of a river?
Oh, I missed that.
Reading comprehension 101. Okay. All right. So W prime of 8, negative 4/5, which means the depth of the river is getting less, or however you want to say it. It doesn't really matter. Just make sure you're careful on how you say it. But yes, there you go. Part B, again, they want a tangent line, so it should not be too hard, because we just went over that now that we've gone over it a few times. So as soon as they use the tangent line, just do it. Tangent line y minus y1 equals mx minus x1. We have to be careful, though. We're doing this at t equals 3. So which function will I use in that piecewise at t equals 3?
The
The
top one.
top one.
Right, so we got to be careful, except this one's much easier because it gives you a pretty easy function. But yes, so just use the top one and go from there. So W of 3, you plug that in, you need to get that. You do W prime and get that. It's really not too bad. Does anybody need me to take the derivative of the top one? I think we should be okay.
Why are
Okay.
you taking the derivative of that one for B?
Because if you're doing a tangent line, what do you need to write the tangent line?
Oh, so.
You need the slope, so you need W prime. So, bless you.
Sorry, I typed in unit, but it didn't work.
You're okay, sweetie. So yeah, just do your y minus y1 m x minus x1 thing. And go from there. So your answer should have been, let's see where we go. So W prime of 3, check your answer, should be pi over 4. And basically you just write your equation in tangent line, get a value. To check your answer, it should be 17 over 2 plus pi over 8. Should be your final, when you plug in the 3.5 like we did earlier, you get that. And that is more than whatever they gave you. Less than 9. I hate that these values were so close, it's dumb. They should have been further away. They did the same thing in the other question. But basically, yeah, it's pretty straightforward. Write the tangent line, plug in 3.5, just like we did earlier. And part C, anytime you see a limit on our free response, just off the top of your head, probably check to see if it's L'Hopital's rule. It's most likely going to be L'Hopital's rule. Not guaranteed, but most of the time. Do we remember the requirements for using L'Hopital's rule in a free response question?
Be 0. It has to be 0 over 0, infinity over infinity.
Okay, and how do we get points for that L'Hopital's rule question? There's
You
something.
show
You
f
have
of
to.
x and g of x.
Fill out each limit,
Yeah.
Very good. Thank you guys
each
for remembering
function.
that. So you do the top, limit of the top, and limit of the bottom separately. So in this case, you should get the limit of the top is 0. Then you do the limit of the bottom. Limit of the bottom is quite easily 0. So you do have 0 over 0. So then you use L'Hopital's rule. And Jesus, this is an ugly answer. You get an answer of, in the end, pi square roots of 3
Ew.
over 8 minus 12. So that's fun. So check your answer, should be pi squared of 3 over 8 minus 12. I would suggest you leave it before anything else. So if you don't plug in, like, use your sine function, plug that all in, you would get pi over 4 sine of pi over 3 minus 12. And I would suggest leaving it like that, as we've talked about many, many times.
Pi over 4 what?
Pi over 4 times sine of pi over 3, all of that minus 12.
Yeesh.
Yeah, when you take the derivative of w, because we're doing it at 2, you have to use the top function. Be very careful. So that's why you get your sine in there from the derivative of the cosine. So it's really not a bad question. It's a pretty straightforward, easy question using L'Hopital's rule. There's nothing too harsh about this one. Like, honestly, number 1 here, I would like, you guys should all have done just fine if you looked at this one. All right, number 2. Oh, they only gave you 1 particle on this one. BC got 2 particles. Okay, so this one's pretty easy. They give you the function for x of t. What does x of t represent again?
Position.
Right. I mean, they tell you the problem, but yes, it's position. So if I want the velocity, v of t, how do I get velocity?
Take the derivative.
Take derivative. So this is a quotient rule. Does anybody need me to show the quotient rule out? I mean, they give you the answer, so you'll know if you got it or not. Anybody need me to show the answer? Just making sure. Okay. Part B is the particle moving toward the origin or away from the origin. So what do we need to analyze to see if it's moving towards the origin or away from the origin?
Hmm.
If it's increasing or decreasing?
What did she just do that breaks all the rules I've given you?
Say it.
Thank you, Miguel. What is it,
If
Deborah?
the function on the graph.
If the function on the graph? What is the function on the graph?
I don't know.
I don't think anybody
Yeah.
knows. That's the problem. Okay.
Is it? No, never mind.
Okay, think about this. What type
VFT.
of problem is this?
Math.
Particle motion.
Particle motion. So it's a motion problem. What are the three things we analyze for motion?
Position, velocity, and acceleration.
Okay, so I'm going to give you one more try, Deborah. Using those three things, how do we tell if the particle is moving towards the origin or away from the origin?
I don't
I really can't answer that.
Okay, let's pretend the origin is your house.
know.
What do I need to know in order for me to determine if you're going towards your house or away from your house?
The direction goes velocity.
Okay, velocity. Is velocity enough to determine if you're moving towards your house or away from your house?
Yeah.
So what else would we need then?
Position.
Position. That is correct. Those two things are the two things that are required to determine if something is moving towards or away from something. For instance, she could be on her street and moving south. Well, if I don't know where she's located, I can't tell you if she's moving towards her house or away from her house. Hold on, I'm getting a call from Miss Palfrey. Got to answer this.
Okay, since he's gone, let's plan to overthrow him.
Right.
Yeah, because that's gonna work. You really haven't noticed he's bald yet?
Yeah, it's like.
No, I noticed that. I just didn't want to say anything. I didn't.
Wait, guys, look on the Twitch stream.
But is
I didn't
it
want to be
like for
like, you
April
got a fresh
Fool's?
cut, didn't you? Like, what if I said
Please
that?
say that.
Just be like, did you get a new shirt? Just say that.
Did you get a new shirt?
I think he can hear everything we're saying, so it doesn't matter.
Also, the chem grades are in, Bridget.
Yup, the chem grades are in, Bridget.
Yeah, the chem grades are in.
Mine are. I just checked.
Wait, she's not even here, bro.
Leave. She was here earlier.
That's facts.
Why are there only 3 people on Twitch? That's what I want to know.
Oh, dang it.
Be on the
Because I
screen.
can't look at the question if I also watch Twitch.
He changed it from his, like, phone to his calculator. That's so
The
sad.
calculator.
Yeah.
Yeah.
Yes. What if he never comes back and he never comes to teach us ever again?
Ever again.
On the phone with Miss Palfrey for the rest of our lives. In 20 years, we're still on the stream, and he comes back and he's like, "All right."
All right, let's get back to it.
Just yelling like that, Nolan. Jesus.
What?
Who just went, ooh?
Your
Jordan's
mom.
dogs.
That sounded like a person going, ooh.
No, it's a dog.
You sure it wasn't Jordan?
No, I'm looking at the dog whining still.
He's slowly choking him the fuck out.
He's slowly suffocating the dog.
Oh, that'd be kind of funny.
All you people with your basic freaking Discord logos.
Shut the fuck up, Will. You literally have. What the fuck is his name? I don't even remember his name.
Just look at
Fuck
me.
it.
Whose face is that, though?
It's your face, but who? What's his name? I don't remember his
The
name.
Snorlax?
Lorax.
Yeah.
Snorlax.
Did you say the Lorax?
God damn it! God damn it! I was so close.
Fucking idiot.
I knew it ended with axe, so let's see.
So you just say Lorax?
Fuck
I'm
off,
the Lorax and I speak for the trees.
My Wi-Fi is messing up.
I thought you said
That
my wife is
sucks.
messing up, and I just.
What are you people cackling about?
Miguel said a Lorax, the Snorlax. Oh, nothing.
Okay.
Oh, nothing. Just
Oh,
love
Hey,
flavored
nothing.
Pop-Tarts.
Just don't forget it is all recorded live. So.
Oh, I
No,
know.
we didn't say anything bad.
Okay. All right. So
You're
to
not
finish
gonna
up,
get banned on Twitch for this.
that would be really bad. Like, what did you get banned for? My kids in class were saying inappropriate things as I was trying to teach them when we don't have access to a classroom. I could just see that conversation now. All right, so to continue our conversation, you need to know where the thing is located in relation to what you're comparing it
Hey,
to.
you just said thing.
Yeah,
That's not.
the thing being because it's a particle. I don't know what the thing is, and I was referencing earlier you, so that's a thing. Um,
Ooh, you get told.
Ow.
you know, thing one, thing two from the Lorax. That's what I was going for. Anybody? Nobody? You guys suck.
Lost me there.
Okay, he made apparently a joke about the Lorax, so I continued the Dr. Seuss theme with thing one and thing two. Jesus.
Well, what's it?
Mine wasn't a joke though. I just didn't remember the name for Snorax or whatever his name
I didn't
is.
say it was a joke. I just said yours was. You said the Lorax. Something happened with the Lorax, so I continued with Dr. Seuss.
Yeah.
All right. So you need to know where the object is in location to what you're comparing it to. So those are the two things you can figure out. Figure out where it's located at 2. Very easy. Just plug in 2 to the position function that they give you. Figure out its velocity at 2, which again they gave you, and then tell me is it moving towards it or away from it. So if you plug in 2 to the position function, you should get a negative 1/4, which means what? What does the fact that you get a negative 1/4 position tell you about the about the object?
It's. I don't know.
What are we comparing the object to again?
The origin.
The origin. So if you get a negative position, what does that tell you about the object?
Moving away.
Careful. Position.
Starts away.
It is located to the left of the origin. Obviously, it has to start away from the origin. If it's starting on the origin, we got some very big problems with this question. So it's to the left of the origin. When you plug in your velocity of 2, you get 7/20, which is a positive number. What does it mean that your velocity is positive?
Would you be moving away? Well, no, you'd be moving towards it.
But that's not the question. You gotta be careful. I'm only asking what does a positive velocity mean?
Going to the right.
It means you're moving to the right in the positive direction. Since we're on the x-axis, left and right are the directions we can travel. So that means you're moving to the right. Okay, now put those two things together. If you're to the left of the origin and you're moving to the right, are you moving towards the origin or away from the origin?
Towards the origin.
Towards.
There you go. There's your explanation. It's exactly what you would say. I start to the left of the origin. I'm moving to the right. Therefore, I'm getting closer. And you would need to mention why those things, like so you would say, because x of 2 is negative, I am to the left. Because v of 2 is positive, I am moving to the right. Those things combine together to tell me I'm moving towards the origin.
That do be making sense.
I try to. Alright, part C. Right, in acceleration, you all should be able to take another derivative. It sucks, don't get me wrong. It's a it's not a fun quotient rule, but it's not terrible. Like, it's not the end of the world. You should all be able to take that derivative. That's an easy thing to do. And then your answer in this case, to check your answer, should have been negative 49/200. So easy derivative to take in essence. I mean, the idea there is easy because it's just a straightforward quotient rule that everybody in this class should be able to do. And then plug in 2. Okay. And again, negative 49 over 200. If you need me to show out that quotient rule, I can do that probably tomorrow since we only have 2 minutes left. And then part D, what position does the particle approach as t approaches infinity? What in the world does that mean?
Yeah, for real. That's what I need to be answered.
Bruh, it's easy.
Parabola.
It means a parabola? You should probably just leave your stuff muted and say your answers out loud to yourself, Deborah. I mean, unless you want to keep getting made fun of. I have no problem making fun of you, but
I
you
don't know.
know.
It's kind of the human interaction is kind of nice.
I know, that's why I do it.
Will it just keep getting bigger? Like
well-
bigger and bigger, the particle itself? Or,
The motion. We're just asking, as t goes to infinity, what position does it reach? In other words, if I plugged in infinity into my position function, what would happen? Well, I can't plug in infinity. Instead, what in calculus can we do as something approaches infinity?
Is it asymptotes?
Parabola.
Yeah, I know it has something to do with asymptotes.
Bruh, what's the only thing in this class we've ever said, as t approaches infinity?
Oh, a limit?
Yay! Thank you, Valeria. It's a limit. Limit as t approaches infinity, as t goes to infinity, of the position function.
Oh.
So it's just a limit question, straight up. Like,
Oh, okay.
super easy limit question. So looking at our position function, t squared minus 9 over 3t squared plus 8, which in Thomas, you were correct earlier, it is an asymptote, so I didn't say that, I forgot to say that. So you're basically looking for the horizontal asymptote is one way you can think of it, or the limit. So what is the limit as t goes to infinity of your position function at the top there? Should be really easily, hopefully.
1/3.
There you go. So as time goes on forever and ever, it eventually approaches the value of 1/3.
Ah.
Alright. Any questions?
Did you get a new shirt?
No? This is a Beihai A shirt.
Well, we can't see it because you're not on the screen.
Yeah,
so.
go back.
This feels sus.
I can hear him getting up.
There. I feel sus.
You got a fresh cut, didn't